Alright, hi you guys and welcome. Today we'll be talking about in AP statistics, we'll be talking about sample size and confidence interval behavior. Now I've used CI just to shorten it up a little bit. Okay, so just to remind ourselves of the formulas, the margin of error plus or minus x bar is the confidence level behavior, and it will actually give us our numbers. So our two numbers could appear in parentheses with our low being over here and our high number being over here, so that we know what the low and high of the range of numbers could be. Okay, now sample size and confidence interval behavior, we can actually do some really cool stuff. Like for example, we could think about what's going on with it. Okay, so first off, if you look at a picture of the confidence level behaviors, just like from an earlier video, you'll find these numbers. Okay, you'll find these numbers working with it. Okay, so as we go down in confidence interval, okay, we can find that our z-score goes down as well. And what does that mean? When your level of confidence goes down, your z-score goes down, the margin of error decreases because now this gets smaller, okay, and the interval width decreases as well. So these go in. Alright, now let's go the reverse way. Obviously, if your confidence level increases, your z-score also increases. Okay, so this margin level also increases, thus expanding this. Which makes sense because what we're doing is we're spreading out our view of what it looks like. Okay, so this is just very nice to be able to sit there and think about, okay, sample size and confidence interval behavior. As confidence interval increases, z-score increases, the margin of error increases, and the spread of the data increases as well, and vice versa. So it's definitely a direct proportion relationship between those two. All right, now what we haven't thought about is what does happen when n works around in its mysterious ways. Okay, so as n increases, okay, that's the number of data points we have, our confidence level, well, our margin of error decreases, okay, which is a very nice thing to actually work with. So, because we're getting closer and closer to normal distributions, that's a very nice thing. Oops, let me get rid of that. Boom, there we go. Okay. Now, what happens to the interval width? It also decreases as well. So the n decreases relates directly with the confidence level decreasing. So the confidence interval. Okay. Now, what if the number of items decreases? Well, that's an inverse relationship. The confidence interval will increase, and thus the margin of error will go. Well, the margin of error will increase, and the interval width increases as well. Okay. All right. So those are some interesting things you got to think about, and it makes sense. The law of large numbers, it really ties into a lot of the stuff we're going to be learning about this chapter. And this chapter, we're going to be talking about proportions. Proportions are huge to work with. Now, p-hat, I was going to talk about this last video, but for some reason had some kind of error with the problem. But for proportions, when you're finding the confidence interval for proportions, you would be using this. This is just the standard deviation for proportions. And for those of you guys that forgot, p-hat is the number of elements we have divided by the number of total elements we could have. So like, for example, if we were testing light bulbs in a factory and 12 on out, we found 12 that went out of a sample of 100, it would be, you know, this number would be 12 divided by 100, or 0.12 would be p-hat. Okay, and just remember p-hat times 1 minus p-hat divided by n would be the standard deviation for proportions, which is kind of like the sample standard deviation. Okay, all right, let's test out some actual problems. Now, oh, here's some really cool stuff that we can. Now, this is going to be kind of a general formula, but let's say a problem's asking you, they want a margin of error of 0.15. And you're like sitting there going, oh, wait, isn't that usually the answer I arrive to? What that means is that you would be solving a problem that looks like this. We would have our z-score times our standard deviation. forgot it for a little bit. Oops. Okay, so basically what you would do is you would work with your margin of error. You would use the z-score that you choose. Okay, and you could choose your z-score to work with it. And what you would do is you would plug in these three parts into these three parts of the equation, okay, and then you would solve for n. So let's say, for example, we wanted a z-score of 95%, or not a z-score, a confidence interval of 95%, and our standard deviation was 5. Okay, so what we would do is we'd set up the problem to look like this: 0.15 equals, and then we would use the 1.96 from our problem. Okay, and then 5 would be right there, and we would divide it by the square root of n. Okay, now what we could do is we can move the parentheses around, and we could remanipulate this equation to look like this: the square root of n equals 1.96 times 5, and we would divide that by the 0.15, and voila, you have your actual problem that you have to work with. Okay, now to finish this problem off, obviously everyone's already saying, oh wait, we just have to square it and then we're good. Yep, just square your answer and you would actually know the number of items that you would need for this problem, which would be 4,268 items that I would need to actually be in my n set, my sample space, so that I could actually find this this margin of error with this confidence interval that I have. All right, that is it pretty much for proportions. Now with proportions, make sure that you do the number of items and divide it by the total number of items in your sample, and you do that proportion right there, and then you could pretty much fill the rest of this out just to work with it. Okay. All right, that's it for sample size and confidence interval behavior. I'll talk to you later. Bye.